Tired of network chaos? Discover how VLANs bring order, security, and speed to your network. Ever wonder why your network slows down or gets overwhelmed with unnecessary traffic? What if you could create dedicated lanes for each department, prioritize crucial traffic like VoIP, and protect sensitive data all with one simple solution? In this video, we'll reveal how VLANs can transform your network from a tangled mess into an efficient, high-performance system. Stay tuned to master VLANs and take control of your network once and for all.
In this network topology, we have several services: DRH, marketing, commercial, and development, which each have their own switches. And yet what you see here is a bad design of the network. If one of the PCs sends a broadcast, then all the switches will spread it all over the network. If the switch of the HR service falls, then the other services will find themselves isolated and will no longer have access to the internet. Because here, PCs must pass through the switch of HR to be able to go out on the internet. Which also means that everyone shares the same bandwidth, which is not great in terms of performance. How many collision domains do you think are represented on this network topology? As each port of a switch is a collision domain, we have a lot of them. 4 on the DRH side, 4 to marketing, 4 in development, 4 sides of salespeople, 1 between the DRH and commercial switch, 1 between marketing and development, 1 between DRH and marketing, 1 between the DRH switch and the top switch, and 1 last one between the top switch and the router. This makes us a total of 21 collision domains. And where are their broadcast domains? If one of the PCs of the switch marketing sends a broadcast, we know that all the other switches will spread it. On the other hand, the broadcasts will not arrive on the router. The Internet Cloud is considered a broadcast domain, so on this topology, we have 2 broadcast domains. 1 domain to the left of the router, and 1 domain to the right of the router. We have seen that this topology is not a good design. That's where the VLANs come in. On this new topology, we have 4 physical switches and 3 virtual networks, better known as VLAN, which are called commercial, marketing, and DRH. A VLAN is a virtual LAN. It's like you have a switch inside a switch. Now let's look at 3 advantages that can be had by using VLAN. A VLAN is a unique broadcast domain, which means that if a user in the VLAN of the marketing department sends a broadcast, then only users of that same VLAN will receive it. The second advantage is that users can only communicate with those of the same VLAN. And the last advantage is that users don't necessarily have to be physically grouped on the same switch. As you can see from this topology, we have users in the commercial VLAN who are on the 1st, 2nd, and 3rd floors. In this example, users of the same service are grouped by VLAN, but we could very well have used the VLAN to separate different types of traffic. For example, a VLAN for all printers, a VLAN for all servers, and even a VLAN for all users. In Voice over IP, the phones are in separate VLAN from the PC data. On an IP phone, there are 2 interfaces. 1 to connect the IP phone to the switch, and 1 to connect it to the PC. This saves a port on the switch and also avoids having a network socket on the desktop. The IP phone will therefore be in the voice VLAN and the PC in the VLAN data. Thus, the traffic will be well separated, thanks to the VLAN, even if there is only 1 cable between the phone and the switch. Separating traffic with the VLAN also allows you to set up a quality of service, better known as QoS. This allows priorities to be set for certain types of traffic. VoIP is extremely sensitive to delay and jitter, which is why it is necessary to ensure that its traffic will always be a priority in case of overload on the network. Now that we've seen the benefits that the VLAN could offer, we will now analyze how the switch manages to differentiate between which VLAN the frames belong to. Here we have two switches with a VLAN voice and a VLAN data. What happens when the A phone wants to call phone B, or PC A wants to send something to PC B? Both switches will transmit traffic, but how are they going to differentiate between the VLANs? To understand, here is the Ethernet frame. Of all the fields in an Ethernet frame, there is no location, or the VLAN number could be specified. That is why we need another protocol to help us. To pass several VLAN between switches, you will have to create a trunk. In the image that has just been displayed, we have PCs on both sides that are in different VLAN. Since an Ethernet frame does not contain fields to specify the VLAN number, the trunk protocol will do so. There are two types of trunk. The 802.1q, which is the most commonly used trunk protocol because it is standard and is supported by many suppliers, and there's the ISL protocol, which is owned by Cisco. Some switches can't stand it. That's why we're going to see the 802.1q protocol in detail. Here's an example of Ethernet 802.1q. As you can see, it's the same tag as a normal Ethernet frame, except that in the middle there's the tag field. It is in this field, tag, that we will find the VLAN ID. That is the VLAN number to which the Ethernet frame belongs. The priority field gives priority to different types of traffic. Each VLAN that passes through the trunk will be tagged, with its VLAN number, by the protocol 802.1q. The only exception is the native VLAN that will never be labeled. By default, this is VLAN 1.